Hello, Algebros. Welcome back from Thanksgiving break. I hope you are refreshed, re-energized, revigorated, and ready to get back to math. Yay! Okay, so we have spent quite a bit of time talking about polynomial functions, whether that be quadratic functions, cubic functions, or more. We have spent a lot of time on polynomial functions. Now we are going to get into rational functions, and let's remind ourselves what rational numbers are. And rational numbers include fractions and decimals, but we're going to focus more on the fraction side. And if you ever had an Algebra 1 teacher or a middle school teacher or whatever the case may be, talk about how fractions are super important. The further along you get in math, the more fractions you use, the more fractions you leave in answers. This is where that comes into play. I know I say it all the time in my other classes that fractions become your best friend down the road. So we're going to focus more on the fraction side of the rational numbers and so on and so forth. So we are going to graph these two functions and compare it to our linear graph, which is just f of x equals x. It is split up into two tables, but it is the same. It's a continuous graph. So why they split it up into two tables, they wanted to show you what happens to negative values or negative integers versus positive integers. All right, so let's get started. So we are going to substitute these values in to our function to see what values we get. So here we would get negative 1 over 1. Okay, so before we go any further, a lot of people are like, well, where does the negative go? Because technically, we're putting the negative 1 in the denominator. But when you're talking about fractions, it really doesn't matter. Is the same as that, which is the same as that. So the negative does not matter where you put it, top or bottom, but typically we just put it on the top or out. Those are the two typical ways of writing it. So I just want you to be clear. We're actually putting the negative 1 in the denominator because we are replacing the x with the x values. And there we go, easy peasy lemon squeezy. We didn't have to do very much calculating. So now let's graph this. What is this going to look like? So remember, or a reminder, or maybe it's new information, I don't know. Whenever you have that function notation like that, that represents the y value. And it's one of those things, if you just accept it, it makes it a lot easier down the road. Anytime you see f of x, g of x, h of x, t of x, s of x, whatever, that represents y. It's representing a function of x, a function of our value. So they create an ordered pair. These would be the y values. These are the x values. And remember, we plot points x, y. So we have negative 1, negative 1. Oh, wrong direction. Sorry. And we have negative 2, negative 1/2, negative 2, negative 1/2. All right, then we have negative 3, negative 1/3, negative. Whoa, that zoom was not planned. Negative 3, negative 1/3. -4, -1/4. -5, -1/5, -6, -1/6. You get the picture. It's getting really close, but it's not quite there, and it will never hit 0. It'll get super close, but it's never going to hit 0. So, we'll wait on that. Okay, same thing with our positive integers. We have 1/1, which is just 1. 1/2. Remember, we're substituting the x values in for the denominator. 1/3, 1/4, 1/5, and 1/6. So we plot those points. Remember, they create an ordered pair. 1, 1. 2, 1/2. 2, 1/2. 3, 1/3. 4, 1/4. 5, 1/5. And 5, 1/6, so on and so forth. So you can see as they approach the y-axis, so if we quickly read this graph from the outside in, as they approach the y-axis, they start to curve up, and as they approach the x-axis, they curve and they don't ever hit it. So these are never going to hit those axes. So when you go to graph, I was doing so good until the very end. They're gonna look like that, something like that. So we completed the table of values, we plotted the points, and we drew a smooth curve. So they're never gonna touch. Now we are going to fill in a third chart. And now they're going to throw some crazy values at us and see what happens. So again, we're going to substitute the x values in for the denominator. So this one's fairly straightforward, -1 over... Again, the negative doesn't matter. I'll put it out to the side so we don't have any confusion. Now, when we start to put in a fraction into a fraction, that's where things get a little tricky. So I'm going to go off to the side over here. And if we have, so 1 over x, remember that we are substituting that whole value in for x. So we have 1 over -1/2. Well, what are fractions? Fractions are just division problems. Anytime you see a fraction, you can divide it out. Anytime you see a division problem, you can write it as a fraction, vice versa. So what this line is really telling us is that it's 1 divided by -1/2. And to refresh your memory, when we are dividing by fractions, you want to flip and multiply. So I'm going to write out those steps for you for this first one, just so we can refresh our memory. So we have 1 divided by -1/2. So if you remember KFC, keep, flip, and change. You keep the first number, you flip the second number, and you change it from multiplication or from division to multiplication, and you multiply straight across, and what we end up getting is -2. So in real time here, 1 divided by -1/10, which would be, you flip and multiply, so you're bringing up and you're multiplying by -10 over 1, which would be -10. Okay, so looking at the pattern, this one's probably going to be -100. 0 is just 0. Actually, that's undefined. Why is that undefined? Let's think about it. Because we'd be putting 0 in the denominator. You can't divide by 0. If you put it into your calculator might just explode, so I wouldn't recommend doing it. But I'm really glad that my computer didn't explode right here, because you can't divide by 0. It's undefined, it's indefinable. You can't put things into 0 groups. It's just not possible. So with that kind of the idea, if you notice, the only value that we are missing in between these two tables is 0. And so they kind of wanted to throw that off for just a little bit so that way we could discover it later. But if you put 0 in the denominator, it is undefined. And what is the y value at the y-axis? Well, it's 0. What is the x value at the x-axis? It is 0. And notice that these graphs don't touch those values because rational functions are undefined when the denominator is 0. It's not always going to be the axis, so don't just take that as that's how it's always going to be. It's not always going to be the axis. So just make that clear right away. It's going to be whenever the denominator is 0. All right, let's continue filling out this chart. If we were to put 1/100th in the denominator, then we would get 100, we would get 10, we would get 2, and 1 here. All right. So I'm going to use a different color. Let's go green. Okay, I'm going to graph these on here, which, let's see what happens. So I have -1, -1, again, -1/2, -2. Boom, and my line is right there. That is awesome. That's just beautiful. -1/10 is gonna be really close, and then we're gonna go down to -10, and then there's no 100, so we're not gonna worry about it. I can't graph the 0 because it's undefined. Let's go back to this side. +1/10 and 10. And then +1/2 and 2. Oh, that one's a little off. Darn. And there. So that kind of just makes our curve a little bit more visual, I guess. You can see the upright curve a little bit more and the downward curve a little bit more. All right, what I want you to do is I want you to use your words. It's on page M2-132, and I want you to describe the graphs, the differences, the similarities, and then describe the end behavior. Remember the end behavior, we want to say what's happening to the graph when the x values are becoming positive, what's happening to the y values when the x values are becoming negative, what's happening to the y values. Okay. All right, I know this was a long video. Hopefully I didn't bore you too much, but for your part of your assignment today, I want you to answer questions B, C, D, and E, kind of in your own words, synthesize what we talked about today.